Imagine a world where video games aren't just pre-built sort of static experiences, but truly live and adapt around you. Generated in real time, responsive to your every command, and maybe even editable on the fly.
Yeah, that's the vision.
We're talking about interactive digital worlds that don't just exist, but truly breathe and evolve with you.
That's the exciting vision, absolutely. And it's a significant leap beyond what we typically think of as video generation.
Right.
So today, for those of you deeply interested in AI and tech papers, we're doing a deep dive into Yann.
Yann, okay.
This is a foundational framework for interactive video generation, and it's tackling some of the, really tough challenges in creating truly dynamic, high-fidelity, AI-driven content.
Okay, so our mission today is to unpack its core modules, understand how they work together.
Exactly, and explore the kind of groundbreaking future they're paving for creative tools and immersive media.
Cool. And for those of you who appreciate the quick hit, maybe we can give that short form summary up front.
Good idea. So the essence of Yann is this. It's a foundational framework designed for real-time interactive video generation. It's really pushing the frontiers of what's possible with AI-driven content creation.
And how does it do that? What are the key pieces?
It achieves this through three pretty remarkable innovations. First, what they call AAA-level simulation.
AAA level, like high-end games.
Precisely. This means generating interactive video at an incredible 1080p resolution and 60 frames per second, complete with intricate realistic physics.
Wow. Okay. That's number one. What's next?
Second, we have multimodal generation.
Multimodal, meaning different kinds of input.
Exactly. This allows for the creation of entire interactive worlds guided by either text prompts or reference images. And it seamlessly blends different styles and mechanics, even expanding scenes dynamically as you play.
Dynamically expanding. Okay. And the third?
And third, multi-granularity editing. This is really cool. It empowers users to modify both the underlying structure and the visual style of the video content.
Oh, you're playing.
In real time, while you're still interacting with it, simply using text prompts.
That's incredible.
Yeah.
So combined, Yann moves us from these, fragmented prototypes we've seen before.
Right, the proof of concept.
To a coherent, truly generative paradigm, offering, it sounds like, unprecedented control and flexibility in these interactive digital experiences.
You got it. That's the big picture.
All right, let's really unpack this for everyone.
Yeah.
Where do we start? Maybe setting the stage.
Yeah, let's zoom out a bit. The concept of interactive generative video, or IGV, is really seen as the next big frontier.
IGV.
Unlike traditional video generation, which, just produces a fixed output.
Like a movie file.
Exactly. IGV dynamically responds to your inputs. It creates personalized visual experiences on the fly.
And the applications, they sound huge.
Oh, yeah. Think about deeply immersive media, highly realistic virtual simulations, or even foundational work for embodied intelligence.
Embodied intelligence.
Yeah.
Like robots learning in simulated worlds.
Precisely. Where AI agents could learn in truly dynamic, responsive environments, it's a big deal.
But the challenge here, it sounds immense. Getting everything right at once.
It is a huge challenge. Achieving high visual fidelity, sustained temporal coherence so it stays consistent over time, and rich interactivity, all simultaneously. That's the hat trick.
And current methods struggle with that.
They often struggle with one or more of those aspects, yeah. The generated content typically remains static after creation. It lacks that real-time adaptability we're, all hoping for.
Which brings us to why games are the testbed here. That's interesting.
It's really insightful, actually. Modern video games exemplify these challenges. They already demand incredibly high standards. 1080p rendering at 60 frames per second.
60 frames, yeah. Super smooth.
Complex physics engines and granular, instantaneous response to every single player input.
Right. You press jump, you expect to jump now.
Exactly. And previous attempts in this space, names like Gaming Gen or Play Gen, they often fell short. Well, maybe on visual quality, or their ability to generalize to new scenarios, or they lacked proper physics, or just couldn't perform in real time.
And critically, they often produced fixed content, not editable.
Right, not something you could truly modify or interact with on the fly in the way Yann promises.
So given these immense challenges that those earlier models bumped up against, how exactly does Yann step in? What are its core solutions?
Yes. Okay, so the paper pinpoints three core solutions. First, they really focus on achieving that high-fidelity, real-time visual experience, making it look and feel like a professional game.
Get the quality up. makes sense.
Second, enabling generalizable and prompt controllable content generation, so you can guide the creation process with simple inputs like text.
More control for the user.
And third, empowering that dynamic interactive editing and on-the-fly content customization during the actual interaction. That's the real game changer, I think.
Yeah, that editing part sounds revolutionary. Okay, and it sounds like the bedrock for all of this is data, a massive data set.
Absolutely. Yann's success truly starts with its data. It's a high-quality interactive video dataset, and it's the shared foundation for all three modules.
And what makes it different from, say, just scraping YouTube?
Well, unlike typical static video datasets, this one includes per-frame interaction annotations.
Per-frame annotations, meaning...
Think of it. Every single frame is tagged with the precise user action that led to it.
Ah, okay, so the model knows why the scene changed.
Exactly. This is absolutely crucial for an AI model to learn responsive behaviors and understand the cause and effect of actions within a dynamic world.
And how do they even build something like that? It sounds like a monumental task.
They developed an automated pipeline, which is clever. They used a modern 3D game called Yann Star as the environment.
Yann Star? Why that game?
It was chosen specifically for its complexity and the sheer diversity of its interactive scenarios. Lots of different things happening.
Okay, and the pipeline itself, how did it collect the data?
The process involved collecting high-precision image-action pair sequences. Basically, observation and action.
Image and action. Got it.
They did this by aligning actions and images via timestamps, capturing screenshots at the exact moment actions were performed.
Very tight synchronization.
Yes, very precise. This ensures the model learns the correct response to actions with minimal delay, which is absolutely vital for that real-time responsiveness.
I can imagine, though, collecting that much data, you'd get a lot of junk, glitches, weird moments. How did they ensure the quality?
You're totally right. Data quality is paramount. They implemented a rigorous multi-stage filtering process. Very thorough.
Like what kind of filters?
Okay, so for instance, a visual filter removed rendering failures or occluded images. It did this by checking for low color variance. Basically, if a frame looked weird or too uniform, just flat color.
It was out. Yeah.
Right. Then an anomaly filter caught things like video stuttering or abnormally high frame counts, indicating lag or some other issue. And a rule filter removed data inconsistent with the game's mechanics, like maybe interactions happening during a preparation phase when they shouldn't be possible.
Using the game's own logic. Smart.
Yeah, this meticulous filtering led to a dataset with incredibly consistent physics and mechanic represented. Really cleaned it up.
That attention to detail is impressive. And after all that filtering, I saw they mentioned using something called a data balancer. What's that for?
The data balancer. Good point. That ensures a uniform distribution across various attributes, like, say, player coordinates or the player's status within the game.
Why is that important?
It's critical to prevent the model from overfitting to just a few common scenarios it saw a lot.
Right, so it doesn't just memorize how to play one level perfectly.
Exactly. By balancing the data, it learns to generate general and diverse interactive video, not just memorizing specific paths or interactions, makes it more robust.
So this isn't just any data. It's really purpose-built for excellence.
Yeah.
Can we recap the key features that make this dataset stand out?
Sure. Well, first, we're talking high resolution, 1080p images. That's 1920 by 1080, captured with an NVIDIA RTX 4060 GPU, so, serious hardware.
Okay, high res. What else?
And they achieved 30 FPS high frame rate videos. They used a clever technique here called action interpolation.
Action interpolation, how does that work?
So they'd send actions 10 times per second, but capture screenshots 30 times per second. Then they'd assign the most recent valid action to the frames in between the actions.
So you get more frames associated with each action.
Right, it gives you those high-precision image-action pairs, ensuring the models learn really accurate responses.
Smart. It sounds like the dataset also covers a really broad range of interactions, like not just walking and jumping.
Oh, absolutely. The dataset features a diverse action space, way beyond just basic movements.
Oh, please.
Includes things like swooping, view turning, specific in-game action.
Which gives the user more freedom, I guess.
Exactly. Enriches user freedom and helps the agent discover more scenes naturally. Plus, it boasts over 90 different interactive scenario styles.
90 styles.
Yeah, grasslands, castles, rainforests, valleys. And critically, it even includes out-of-domain test scenarios.
Meaning environments the model never saw during training.
Correct. To really push its generalization capabilities. See if it can handle something totally new.
And the scale. The number you mentioned earlier was huge.
Staggering, isn't it? Over 400 million frames of interactive video data.
400 million. How does that compare to others?
Well, just for perspective, other efforts like PlayGen had, I think, 128p resolution and 250 million frames. Or Game Factory was maybe 360p and only 4 million frames.
So Yann's dataset is just orders of magnitude better in resolution, precision, diversity.
Pretty much, yeah. Superior on multiple fronts. That really is the bedrock for everything else they achieve. You need that quality input.
It truly is. Okay, so with that incredible data foundation laid, let's dive into the first core module. Yansim, the AAA-level simulation engine.
Right, Yansim. The promise here is achieving that high-fidelity, real-time rendering and physics simulation. It translates your user actions into fluid 1080p at 60 frames per second interactive visuals.
60 frames per second generated video. That's fast.
It is. Think of it like playing a high-end game, but the entire game world itself is being generated on the fly, responding instantly to your moves.
Sounds like actual magic. How does it work under the hood? What's special about their model architecture? Is it just stable diffusion?
Well, it builds on the Stable Diffusion framework, but with substantial enhancements. It's not just off the shelf.
Right.
What's truly innovative is how they re-engineered the core visual compression part. Their 3D VAE, that's variational autoencoder.
Right, the part that compresses the images.
Exactly. It's incredibly efficient. They increased spatial downsampling from the usual 8x to 32x.
32 times smaller spatially.
Yeah, and temporal downsampling to 2x. It essentially packs far more visual information into much smaller, highly compressed digital representations or latents.
Which is crucial for speed, right? Processing smaller things.
Absolutely crucial for real-time processing. They also expanded the latent channel dimension to 16 for even higher information density, so small but information-rich.
Okay, so a super efficient way to encode all that visual information. What about the diffusion model itself, the part that generates the frames? How does it handle doing that frame by frame while staying interactive?
Good question. The diffusion model is specifically adapted for what's called autoregressive frame-by-frame inference.
Autoregressive meaning it predicts the next frame based on previous ones.
Exactly. It uses standard spatial attention, like in many image models,
Yeah.
but critically, it incorporates action cross-attention.
Action cross-attention, what does that do?
This is where a separate little network, a multi-layer perceptron, processes the action signals what button you pressed into high-dimensional tokens.
Okay.
And these action tokens are then injected into each visual frame's processing, basically telling the model what action just happened.
So the model knows what the user did.
Right. And crucially, to ensure that real-time interactivity, it uses causal 1D temporal attention.
Causal,
Meaning it only ever looks at past frames to predict the next one. It never cheats by peeking into the future. That's essential for true interactivity, where the future depends on your current action.
That makes sense. Okay, it sounds like they pulled out every trick in the book to optimize this thing for speed. What kind of performance boosters did they implement?
Oh, they absolutely did. It's a real masterclass in performance engineering, actually.
I caught.
So, Yansim is trained in 2 stages. First, the VAE, then the diffusion model, using that massive game data set we talked about.
Right.
During inference, when it's actually generating video, it uses an optimized technique called de-Dimon sampling. This lets it create high-quality images with far fewer computational steps.
Fewer steps means faster generation.
Dramatically faster. They got it down to just 4 denoising steps per frame, which is incredibly low for diffusion models.
4 steps. Wow. But they didn't stop there, did they? I remember reading about more optimizations.
You bet. They went further. This included things like making the core model leaner through structural pruning of its UNet architecture.
Cutting out unnecessary parts of the network.
Exactly. Using highly efficient data formats like FP8 quantization. That alone yields like a 1.5 to 2 times speed up over the more common FP16 format.
FP8. That's pretty cutting edge for speeding things up.
It is. They also streamlined the whole software process. They captured the entire pipeline as a single CUDA graph to eliminate overhead between steps.
Minimizing software latency.
Right, leveraging custom Triton kernels for specific operations, and even using torch.compile for another like 1.15x boost.
They can put different parts on different GPUs.
Yeah. Deploying the VAE and diffusion models on separate GPUs with a queue between them to avoid serial latency. One processes while the other waits, kind of. It's a real testament to their dedication to hitting that real-time performance target.
That level of optimization is genuinely impressive for, the technical folks listening. So, How does all this hardcore engineering translate into actual real-world impact within the generated game world?
It translates into really remarkable results. Yansim faithfully reproduces diverse artistic styles and intricate details, all at high resolutions and frame rates. They mention maintaining, for example, a solid 62 FPS, even in complex scenes.
62 FPS. That's smoother than many actual games run.
Right. And it also shows strong motion consistency. It responds accurately to your inputs, generating the correct feedback in subsequent frames, mirroring that fluid feel of real gameplay.
And you mentioned the physics simulation, that it's not just pretty pictures.
Precisely. This gets really interesting. It realistically replicates world physics.
Like what? Can you give examples?
Think of the character's inertia when they're sliding down a water slide, or being unable to move after touching an electric fence, the correct stun effect, or bouncing higher on a trampoline.
So the interactions feel right.
Exactly. These aren't just visual effects slapped on. The underlying simulated mechanics are actually correct, learned from the data. Plus, it maintains high visual consistency over extended interactive sessions.
So it doesn't just fall apart after 10 seconds.
Right. Proving its long video generation capability, Yansim truly lays a solid foundation for these AAA-level interactive experiences. It's the engine.
Okay, engine built. Let's move to the next module. Yann, Multimodal World Generation. The vision here, you said, is real-time interactive world generation from text or images.
That's the goal, yeah. Pushing beyond the static content limitations of previous models.
And what was the biggest hurdle they had to overcome here?
The key challenge it solves is something called semantic drift.
Semantic drift.
Yeah.
Like the model forgets what it was supposed to be generating.
Kinda, yeah. Where autoregressive models, because they generate step by step, tend to lose coherence or forget the initial context over long sequences. It's a common problem in generative AI. Things just drift away from the original idea.
Okay, so how do they stop that drift? Yann introduces this hierarchical captioning method.
Exactly. It's quite ingenious, this hierarchical captioning, which they power using Qwen 2.5 VL.
Qwen 2.5 VL, that's one of those big multimodal models, right? Understands images and text.
Yes, a powerful large language and vision model. It's designed to understand complex visual and textual instructions. They use it to inject game-specific knowledge into their video diffusion models and provide a stable, multi-layered context.
Multi-layered context. How does that work?
Think of it like this. There's global captioning. This is a single overarching caption describing the static characteristics of the entire world.
Like the overall theme, Cyberpunk City at night.
Exactly. Layout, visual theme, lighting, weather. This acts as a constant, unwavering reference point. It anchors the generation, preventing the model from losing its way over time.
Okay, so a global anchor. What's the other layer?
Then, for shorter dynamic segments, typically about 3 seconds long, there's local captioning.
More specific.
Much more specific. Detailed descriptions of transient events, like the local scene right around the player, interactive objects nearby, or critical events happening right now.
So it keeps track of the immediate situation too.
Right. This ensures fine-grained accuracy for immediate actions and changes. It's like having, a master plan for the whole world, but also incredibly detailed immediate instructions for what's happening right this second.
That makes a lot of sense for maintaining coherence. Okay, and the training journey for Yann sounds quite involved. Any highlights there?
It is multi-stage, yeah. It starts by fine-tuning a pre-trained video model they mention, using one called Yann with these hierarchical captions. They use LoRa for this.
LoRa, low-rank adaptation. That's for efficient fine-tuning, right?
Exactly. It's very correct. Then, an interactive module is trained specifically to incorporate those action-based conditions we talked about, using a dedicated action encoder and cross-attention again.
Okay, teaching it to respond to actions.
Then it's converted into a causal autoregressive model like Yansim, and finally, it's further distilled into a highly efficient few-step generator.
Distilled, making it faster.
Yeah, using techniques like distribution matching distillation, DMD, and self-forcing. These essentially teach a smaller, faster model to mimic the output of the larger, slower model, making it more confident and quicker with fewer steps.
A lot of steps, but sounds like a solid pipeline. So once it's trained, what are some of these generative superpowers you mentioned? What can you actually do with Yann?
Okay, this is where it gets really exciting. You get things like text-guided expansion.
Expanding the world with text.
Yeah. You can dynamically expand a scene simply by providing modified textual descriptors. Imagine starting in, say, a disco-themed environment. And then, with a simple text prompt like, change to classical musician scene. You watch it fluidly morph around you as you move, all while maintaining structural continuity.
Whoa, that's like lucid dreaming with prompts.
Kind of. Then there's image to interaction.
Generating a playable world from a picture.
Exactly. You provide a single reference image, and Yann generates an interactive world around it. The paper shows examples like an astronaut character moving realistically on the moon based on a moon image.
Or that Husky example.
Yeah, or an animated Husky character running through a desert environment generated from a desert photo.
Yeah.
All based on just that initial image, but with consistent real-time responsiveness to your controls.
That's incredible. You're not just making a video of the image, you're making a playable experience from it.
That's the key difference. And it also demonstrates strong cross-domain fusion.
Fusing different styles or realities.
Yeah, it can seamlessly blend knowledge from different domains. You could take an out-of-domain reference image, maybe a real-world photo of a desert landscape.
Okay, something the game engine never saw.
And combine it with an in-domain character, like that animated Husky from the game environment they trained on. And it creates interactive cross-domain scenarios where the Husky runs believably in the photorealistic desert.
Wow. So no more awkwardly pasting a cartoon character into a photo background and calling it a day. This sounds like a dream for content creators, mixing and matching styles seamlessly.
It really opens up possibilities.
And what about performance for Yann? Does it keep up with all this heavy lifting?
Its performance is pretty impressive for what it's doing. Yann can achieve around 12 to 17 FPS on a single NVIDIA H20 GPU.
Okay, maybe a little choppy, but usable.
But it can scale up to 30 FPS using 4 NVIDIA H20s.
Parallel processing.
Right. This allows for real-time, infinite content generation and that dynamic prompt adaptation we discussed, which is crucial for a truly interactive experience.
Okay, impressive stuff. Now, for what sounds like the ultimate level of control, let's explore Yann Edit, Multi-Granularity Editing.
Yann Edit, yeah.
This is the text-driven interactive video editing model. It lets users modify content during interaction, so you can literally change the world around you, not just interact with a fixed one. That's genuinely wild.
It really is. It feels like the next step. And the core innovation here, the really clever part, is how it explicitly disentangles the interactive mechanics simulation from the visual rendering.
Disentangles mechanics from visuals.
Right.
Okay, that sounds fundamental.
Yeah.
How do you change, say, the color or even the type of an object without breaking how you interact with it?
Yeah.
That seems like the core challenge.
That's precisely the problem they aim to solve. How do you change the appearance without breaking the physics? Yann Edit's ingenious solution is this. First, it extracts a depth map for each frame.
A depth map, like a 3D scan of the scene's structure.
Sort of, yeah. Think of it as capturing the 3D structure, how far away objects are, their shape, but without any visual information like color or texture, just the geometry.
Okay, structure only. Then what?
Then the interactive mechanics simulator, which actually leverages Yansim, the first module, as its base, learns the interactive physics solely from these depth maps.
So it simulates based only on the shapes.
Exactly. It generates the next depth frames based on your user actions and a specific structure text prompt.
A structure prompt, like change platform to door.
Precisely. This ensures that if you, for instance, prompt to change a rotating platform in the game to a wooden door, the physics simulation updates accordingly. How you interact with it, its collision properties, its movement potential, all that remains accurate and consistent because it's only dealing with the underlying structure defined by the depth map and the structure prompt.
Okay, so the physics simulation runs on the structure. But how does that structural information get turned back into a visually rich, textured world?
That's where the second part comes in, the visual renderer. This module takes those depth frames generated by the mechanics simulator.
The structural blueprints, basically.
It renders them into the final video, but this rendering is guided by a separate style text prompt.
So make it look like bamboo watercolor or something.
Exactly. It uses Yann powerful generative capabilities, the module we just discussed, but with ControlNet integration.
ControlNet. That's used a lot in image generation to guide outputs, right?
Yes. It's a technique that lets you guide image generation based on various inputs, like depth maps in this case. It ensures the visual output accurately follows the structural guides provided by the depth map while applying the style from the style prompt.
This separation sounds like it enables true dynamic customization in action. Can you give some concrete examples of what users can actually do with Yann Edit?
Certainly. For structure editing, you get real-time dynamic content creation and replacement. So, like the example before, you could be playing in a world and type a prompt to switch a rotate plat to a wooden door.
And poof, it changes.
And poof, the environment changes immediately and interactively without a hitch. The physics update, the visuals update.
That's amazing for level design on the fly or just messing around. And style editing.
And for style editing, you can modify the color and texture of objects, or the whole scene's aesthetic. Imagine starting in, say, a bamboo and watercolor style world.
Okay, nice aesthetic.
Then mid-game, you type a new prompt to switch to maybe purple glass and cyan light.
Totally different vibe.
And then later maybe to snow and soft pastel shading, all while the game's interactive mechanics, the physics, remain perfectly consistent because they're handled separately by the structure simulator.
Wow, it's like having a master art director on call who can just repaint the entire world around you in real time without skipping a beat.
That's a great way to put it. It's incredibly powerful. And the whole system works frame by frame. They use KV caching.
Caching. Storing previous calculations to speed things up.
Exactly. It's a standard technique in transformer models, like the diffusion models here, to store and reuse past computational results. This greatly speeds up sequential generation and helps maintain temporal consistency. It allows users to input new structure or style prompts at basically any moment during interaction.
It's clear that Yann is, well, revolutionary. But like any cutting-edge research, it probably still faces some limitations, right? What stands out to you as its current boundaries?
You're right, no system is perfect, especially this early. Maintaining perfect visual coherence over extremely long and crucially rapidly changing interactive sessions remains a challenge. The more you edit and change things on the fly, the harder it is for the model to keep everything absolutely consistent over, say, hours of gameplay.
Things might start looking a bit weird eventually.
Potentially, yeah. Little inconsistencies might creep in. That's an area for improvement.
And for us technical folks, I have to imagine the hardware requirements are pretty steep right now.
Oh, definitely. That's a big one. Its high-fidelity, real-time performance currently demands powerful GPUs. We're talking high-end NVIDIA hardware.
So not running on your average laptop anytime soon?
Not yet, no. This does limit accessibility for now. More efficient architectures, maybe model distillation, quantization for lower resource devices. That's a clear future direction the researchers acknowledge.
What else? Any other limitations?
Well, the complexity of its action space, while diverse for the game, is still somewhat bounded by that underlying Yanmeng star environment used for training.
So it might struggle with actions totally outside that game's scope.
It might, yeah. Restricting its full real-world extensibility beyond game-like scenarios is something to consider. And while the editing module is powerful, relying solely on textual descriptions...
might not always be intuitive.
Exactly. It could benefit from more intuitive and broader user control, perhaps integrating visual editing tools or more nuanced language understanding.
Makes sense. So knowing these limitations, what are the researchers planning next? What's on the road ahead for Yann?
They plan to focus on scaling both the dataset size and diversity and the model capacity while simultaneously, and this is key, rigorously improving efficiency, making it run faster on less powerful hardware.
Scaling up and slimming down. Got it.
They also aim to extend that prompt controllability to real-world domains beyond games. Imagine using this to simulate real-world environments for robotics training or maybe urban planning simulations.
Taking it out of the virtual playground.
Right. And crucially, they intend to develop richer evaluation protocols. How do we even measure success for these kinds of systems? It needs to account for human factors, user experience, and safety, especially as these interactive AI worlds become more complex and immersive.
Evaluating the experience, not just the pixel accuracy. Good point.
Yeah.
Wow, what an incredible deep dive into Yann this has been.
It's really fascinating stuff.
This foundational framework, unifying that AAA-level simulation, the multimodal generation, and the multi-granularity editing, it truly marks a significant milestone in AI-powered interactive content.
I agree. It vividly bridges the gap between simulation creation and that really exciting on-the-fly customization.
It really does. As AI continues its rapid advance, tools like Yann offers this compelling glimpse into a future where our digital experiences aren't just pre-rendered scenes,
but truly living, breathing, and infinitely malleable worlds. It's a paradigm shift.
So for you, our listener, the provocative thought maybe is, what does this mean for the next generation of creative tools, media, and entertainment? Imagine game designers filmmakers, maybe even educators, creating interactive experiences that fundamentally respond to and evolve with your individual thoughts and actions in real time.
It changes the relationship between creator and consumer.
Completely. How might this reshape the very nature of digital storytelling and virtual engagement, moving us from passive consumption to active, real-time co-creation?
It's a truly thought-provoking prospect, for sure. Where does interaction end and creation begin?
Exactly. Something to chew on.